All right, Algebra 2, I'm going to make this the main lecture. I will say this about what we're into. This is a lot of information that we're going into, and you will have a cheat sheet more or less that allows you to like check your cheat sheet. I don't know what it looks like all the way, but I know we have one. So your notes, you need to keep your notes for sure. You're going to need this. With that said, I actually like these notes. These notes tell you exactly what we're doing and exactly what's going on. So we're basically dealing with rational functions. Periods 1 through 3 got to deal with 10-1, so they won't be completely blind, but periods 5 and 6, I just skipped it because of the absences. So y'all are going to have to like struggle a little bit more in period 5 and 6 to keep up with this. With that said, I'm going to go ahead and talk about this. So the first thing I'm going to do is I'm going to take you to Desmos and show you what 1 over x looks like. Here is what 1 over x looks like, right here. See this shape? This is where it comes from. I can basically, on my bottom right here, let's say I did minus 4. You see how it moves over 4 from the original position? If you don't know what I'm talking about, I'll change it. Boom. Boom. Okay, cool. So the x's always lie. That's the same. So let's get that back to the middle. Now look at our y's. If I did plus 3, it moves up 3. If I did minus 3, it moves down 3. So that's what we're dealing with here. And for those who don't know, like if you want to see some cool little, what's it called? Asymptote business right here, check it out. So look at this number here, -3. Look how it forms an asymptote. If you don't know what asymptotes are, it's that line where your graph is approaching it but never actually touches it. And then we have our x equals 2. You set your denominator equal to 0 to find out what it equals to. And in this case, we can get asymptotes. You can get holes as well too, but you can also get asymptotes. So that's the basics of this. You can see the relationship between the asymptote of x equals 2 comes from here. The bottom, you can see the relationship of the y equals -3 comes from here. And once again, x is always lie. So that's all you missed yesterday. With that said, I'm going to go back to here and talk about how this stuff works. Today, what's happening is we are going to be doing more complicated rationals, and you're going to be responsible for holes and special case asymptotes. So with that said, these are your things you have to know. This is the hole. The p of x represents the top of your rational right here. The q of x represents the denominator. And so if you know how to read this, you basically can figure out everything. So go ahead and go read through this, what you need to do. This is kind of hard to say. Horizontal asymptotes. This is the metrics for doing this. I don't have this memorized. Like I'll have it memorized by the end of the, end of the week and then forget it for next year. But this is something we're definitely going to be using. So I'm not going to spend a bunch of time talking about the notes now. That's just what you missed from yesterday. What I'm going to do is I'm going to model a problem and then come use my check sheet to make sure I have this right. So let's go ahead and talk about number 1. The first thing you have to do is you have to check for factoring anywhere. So you have to factor on top, that's the numerator, and you have to factor on bottom, that's the denominator. So on this first one, I'm going to go ahead and get started. I'm going to use my black ink, and I'm going to go ahead and write this. So check out example number 1. I can basically rewrite this, and I'm going to rewrite this as, it says factor first if possible. I have my x minus 2 on top, and then I'm going to take this out, and I have 3 times x plus 2 on the bottom. This doesn't really help anything for us. Holes happen when there is a cancellation, so I'm going to show you what I mean by that. I'll make a little problem up. I'm going to make a little problem up real fast here. We'll do a 4 over here, and if I had x minus 2, and then let's say x plus 2, or x plus 3. Okay, so what do I mean by holes? Well, check this out. If I had this situation here and I crossed out that and crossed out that, then what would my hole be for this example? Well, it would be x equals 2. It's kind of hard to see without Desmos. You'll just have to accept it for right now. You can graph on Desmos and check some of these. But when you have something that cancels out in the numerator and something that cancels out in the denominator, that's where a hole appears. So do you see any cancellations? The answer is no. So did anything cancel out? No. So there's no holes. And again, this purple was just a made-up problem. So then holes, no, there are none. The vertical asymptote. All right, I'm going to go ahead and take you to our, what's it called? Sheet over here. Vertical asymptote is right, it's right here. So use your notes and say, what does it say for the vertical asymptote? It says set the denominator equal to 0 and solve. Okay. Set the denominator equal to 0 and solve. That's what it said for this particular vertical asymptotes. So I'm going to set it equal to 0 and solve. And I'm just going to basically use my x plus 2. So I have x plus 2 equals 0. And that gives me x equals minus 2. So I basically have a vertical asymptote at x equals negative 2, which is awesome. Now what I'm going to do is I'm going to go ahead and take you down to the horizontal asymptote. Let's go look at horizontal asymptote. The rules for horizontal asymptote are right here, determined by the degrees of px and qx. What is a degree? For those who don't know what a degree is, it's this. It's the biggest exponent on the top. So here's a made-up example. If I had 4x to the fourth plus 3x to the third plus 2x to the 2 over, let's see, I'll have 5. Let's do 6x to the 5. And then I had, I don't know, 4x to the 7th plus 8. The degree on the numerator, in this case, the numerator's degree, and again, you don't have to write this down. The numerator, the degree is 5. It's the biggest exponent. In this case, and the denominator, the degree is 7. So it's the biggest exponent that you get there. So you have to basically look at this. So when it says the numerator degree is less than the denominator degree, all right, you have a horizontal asymptote at y equals 0. Good enough. Let's go check what we got here. I have a 1 and a 1. So my degree on the top, and this is how I would do it, I would say my degree numerator. Make sure you label it. My degree for my numerator is, Mister, there's no numbers up here. Yes, there is. If there's no x, if there's nothing here, it's x to the 1. So the degree numerator is 1. The degree of the denominator is also 1. That's the highest x, or the actual, what is that called? Exponent that we have. So what's the rule? The rule is if they're equal to each other, you go a over b. You do a over b, a over b. All right, that seems pretty straightforward. So what is my a over b in this case? Well, quite frankly, it's right here. You go to the original equation. Go to the original equation, and what do I have? I'm going to go ahead and mark this in blue so you can see it. I'm going to be looking at this one, and I'm going to be looking at this one. And so what do I have in this case? Well, a is equal to 1. It's the number in front of x. In this case, my b is equal to 3. So there we have it. I have 3 right there. So it says to put it together as 1 over 3. Hooray for us. That's where I'm getting that from. Going on to the next problem, x-intercept. All right, let's go check what it says for our x-intercept. X-intercepts, here's the list. It says the real zeros of the px, the numerator, blah, blah, blah. Set the numerator equal to 0 and then solve. So that's our x-intercepts. All right, seems simple enough right there. I'm down with that. Let's do it. Set the numerator equal to 0 and solve. Set numerator equal to 0 and solve. All right, what is my numerator in this particular problem? It is x minus 2. So I have x minus 2 equals 0. So then what do I have? Is that right? Oh, yeah, I do. Yeah, x minus 2 equals 0. So then x equals 2. So then when I'm all said and done, I have x equals 2. All right, I'm going to switch back to my black ink, and then y-intercept. Let's see what it says for our y-intercept. You see how so far I'm not memorizing anything? You will eventually memorize some of these, but for today, I want you to know how to use them. So it says solve of f of 0. So basically it means for the y-intercepts, you have to plug in 0 into x. So you plug in a 0 anywhere you see an x. You plug in a 0 anywhere you see x. So I have an x minus 2 and a 3x plus 6. So I have an x minus 2, I have an x minus 2, and a 3x plus 6. So now what I'm going to do is I'm going to plug in 0 everywhere. 0 minus 2 equals negative 2. That's my top part. 3x plus 6. 3 times 0 plus 6. 3 times 0 is 0. Plus 6 is 6, so that gives me negative 2 over 6, which when reduced gives me negative 1/3. So the y-intercept is negative 1/3. And then we basically have to look at our domain and range. And what does it say for our domain and range? Let's look. It says all the x values except where vertical asymptotes are x of holes. Okay, so if there are holes or vertical asymptotes, then that's where we're going to have domain things going on. So let me talk about what I mean there. So what does that mean? Let's look. Do I have any holes? No, I do not. Do I have a vertical asymptote? Yes, I do. I have one at x equals -2. So this is the only number that can't equal, that can't be put into the equation. So everything, I'm going to write it the easy way. You ready? The domain, it can't be a vertical asymptote, which is x is equal to -2. So it cannot equal that, and then there are no holes. So the domain is basically all reals. The domain is all real, but x cannot equal -2. Let me go back to my cheat sheet and see what I got here. Now my my range. Y values except horizontal asymptotes or the Y holes. Well, we have no holes. And do we have a horizontal asymptote? We do, 1/3. So then the range is all reals. The range is all reals. And that's that weird R. Sorry, I'm terrible at doing that. Actually, let me redraw it. I never learned how to draw these properly, so they kind of just look like a weird, stupid R. That's fine. All reals except that Y cannot equal, and what do we find? 1/3. Y cannot equal 1/3. For anybody who's following this and it's like, oh my God, I don't know what's going on. Duh, it's called learning. Like, replay the video then. With that said, I am going to call this a done deal for the videos. I don't want to do any more than this. This is a lot. But I probably will put some answers up as we go. So tomorrow, for instance, we're doing this again. I'll probably solve some more problems tomorrow after the basics are down. That's it. See you in class.